substitution method. As a reminder, a system of equations is two or more equations, and a solution to a system of equations is a point or points that they have in common or that they share. For substitution method, it is what its name implies. We will substitute information from one equation into the other equation. Pick an equation to isolate a variable and isolate it is going to be your first step. So if I'm taking a look here, I'm going to pick one of these equations. I want to do the easiest one possible. So I wouldn't do this one because not all terms are divisible by 3, not all terms are divisible by 7. I'd get fractions there. But if I look here, x is already almost by itself, and each of those numbers is divisible by 5. And what that means is I will get all whole numbers, which is really nice to work with. So that gives me x equals 3 minus 2y. So step 1, isolate a variable. I've done that. Step 2, take that expression and plug it in for that very same variable, so x, into the other equation. It's really important you don't substitute it back into the one that you rewrote. It has to be the other one. So that gives me 3 times the expression 3 minus 2y plus 7y equals 31. And I'll do the solving from there. Distribute the 3 to each term. That gives me 9 minus 6y plus 7y equals 31. I do have some like terms that I can combine. So that would give me 9 plus y equals 31. Subtract 9 from each side to get y fully by itself. That gives me 22. Step 3, you're going to take that solution, plug it back into, you could do one of the original, but it really is easiest if you go back to your step 1. So I'm going to take 22, plug it in for y. So that gives me x equals 3 minus 2 times 22, or that gives me 3 minus 44, which is a negative 41. So x equals a negative 41. Keep in mind, your answer is a coordinate. It's a point of intersection. So you should always do a coordinate where your x is first, your y is second. So that's my final answer right there. Let's do another one. Once again, pick the one that's easiest. So all of these are divisible by 2 and y is already almost by itself. I probably would do that one. You could have just as easily tried to isolate y here. So I probably would add y to get a positive y and then add 7. So that's 3x plus 7. Really, it's kind of up to you. I'm going to do this one just because I feel like it's one step instead of 2 steps. Again, it is totally your choice which equation you use, which variable you want to solve for. You just have to make sure that you're picking what's easiest for you. So again, I chose this because I just divide each side by 2 and I get nice whole numbers. Love that. So step 1's complete. I isolated y. I'm going to take that. I'm going to substitute it into the other equation. So it's really important you don't go back to the one you just rewrote. You go to the other one. Now when I substitute it in, it's 3x minus y, minus this entire expression. Sometimes I see some sign mistakes here. If I'm subtracting the entire expression, what that means is I'm going to distribute that negative, understood to be 1, to each of the terms. So that's 3x, negative 1 times 5x is negative 5x, negative 1 times 9 is negative 9, and then I'm going to solve for x. Combine like terms, negative 2x minus 9 equals negative 7, add 9 to each side, negative 2x equals 2, divide each side by negative 2, that gives me x equals negative 1. And then take that, plug it back into that step 1, just because that's going to be super easy if you do it that way. That gives me y equals 5 times negative 1 plus 9. That gives me y equals negative 5 plus 9, or y equals 4. Now that I have my x and y, I'm ready to write my final answer, which is a coordinate, x, comma, y. So negative 1, 4. All right, taking a look at the next part of the notes. We have a little bit more complicated of a system, okay? X and Y is not super close to being isolated yet. If I take a look at equation 1 versus equation 2 for step 1, which is to isolate a variable, all of these numbers are not divisible by 3. All of these numbers are not divisible by the 7, so I'm not going to do that one. For this one, if I'm saying are they all divisible by 7 or all divisible by 14, 7 is the one I want to do. So I'm going to use equation 1 because that's just going to make it easier for myself. And then I'm going to solve for x because all my terms are divisible by that 7. Before I go ahead and divide, though, I am going to move this 14y over to the other side using subtraction. So negative x equals negative 14y minus 14. Now I'm going to divide each side by that negative 7. That gives me x equals negative divided by negative is a positive. Negative divided by negative is a positive. So this is what I got for my expression, 2y plus 2. Take this, plug it back into the other one, the one you did not just rewrite, and substitute it in for the x since you just solved for x. So for my step 2, I have negative 3 times that 2y plus 2 that I'm substituting in for x plus 7y equals negative 3, and I'm going to solve for there. Distribute that negative 3 to each term. Combine like terms, that gives me y minus 6 equals negative 3. Add 6 to each side, that gives me y equals positive 3. Take that y equals 3, plug it back into step 1, so x equals 2 times 3 plus 2, or that gives me 6 plus 2, so x equals 8. Your coordinate then is 8, 3. This next one is a try problem, so I want you to go ahead and pause the video, attempt it. When it's time for you to check, here's my work so you can pause it and look. You should have ended up with 0, negative 3.